Graphing linear equations. We're going to learn three methods to graph a linear equation. Let's start with the slope-intercept form, which we've already covered in another lesson with further detail. Remember, step one is to identify the slope and the y-intercept. Here's your guide. The slope, remember, is the coefficient of x, that's the number right next to x, and the y-intercept is the constant, that's the number over here by itself. Keep in mind, sometimes your constant may be thrown in the front, so the order does not matter in this case. What's important is that, again, the coefficient of x, whatever's next to the x, that is your slope. So in this problem here, we have -4 as a coefficient of x, meaning -4 is our slope. And remember, it's helpful when graphing, if you don't already see this in your head, to write this number as a fraction, because that will help us when using the rise over run in step 2. And our y-intercept is the constant here, +3. So we start first, as step 2 says, by plotting our y-intercept, which is 3. Again, that must go on the y-axis since it is our y-intercept. From that point, we need to follow the direction of our slope. -4 means go down 4 units, 1, 2, 3, 4, and that +1 means 1 to the right. Remember, you could draw your line using a straight edge from here, or, as I've guided you, so that you don't have to use a straight edge, just continue the pattern. 1, 2, 3, 4, 1 to the right. 1, 2, 3, 4, 1 to the right. And then you can follow the pattern in the opposite direction as well. You can go 4 up, 4 units up, and 1 to the left. 4 units up, 1 to the left. Once you have all of your points, go ahead and connect these as I wrote in step 3 by drawing a line across your points. So here you have the slope-intercept form. The second method is the point-slope form. In the point-slope form, similarly to the first method, we are given a point, though it's not on the y-axis this time. The point we are given, you might consider as being in a random place on our coordinate plane. From that point, we will use the slope to get the rest of the points, just as we did in the first method. So let's go ahead and start. Little trick I give you here is to use the opposite sign when identifying the x1 and y1 values. So let me explain what I mean by that. When you look for the x1 value here next to the x, -4, you're going to take that as a +4 because realistically, 4 is the number that's being subtracted here. Now, when you look at this +7, you're really going to write it as the opposite, -7. And again, I have explained this with further detail in class. That's because we're really subtracting a -7. But for now, just remember, take the opposite sign of what you see here. For the slope, we have the value -4/5. -4/5. Now let's go ahead and start plotting. Let's start by plotting our point for -7. Find that point for -7. Let's plot that on our graph. From this point, remember, we're going to use our slope. Now we're slightly going outside our boundaries, but that's okay because we can still fit the point here. We have 1, 2, 3, 4 down. 1, 2, 3, 4, 5 to the right. If for whatever reason you ever end up outside of your graph and you don't need to draw more lines to extend your graph, remember you can just count in the opposite direction. Rather than going down 4, 5 to the right, you would go up 4 and 5 to the left and continue that pattern from there. So up 4, 5 to the left, up 4, 5 to the left, and once you have your points or a straight edge, remember you can go ahead and draw your line across your points. That's the point-slope form. Lastly, we have the standard form. Note that the standard form has both the x and the y values, or terms rather, on the left side of the equation, or more importantly, together on the same side of the equation. They can both be on the right side or the left side, as they are in this case. So that's how you can identify that you need to use the standard form. Both the x and the y are on the same side of the equal sign. Now, let's start by finding the x and y intercepts. Let me show you how to do that. So to find our x and y intercepts, we will take our equation 2x minus 5y equals 20. The first time around to find the x-intercept, we will plug in 0 for the value of y. Then to find our y-intercept, we will plug in 0 for the value of x. And from our previous lesson, you should see there in the definitions that we discussed that the x value of our y-intercept is always 0, and the y value of our x-intercept is always 0. That's why we're plugging in 0. Now, the nice thing here is that when you multiply anything by 0, it simply becomes 0, or you can think of it as it goes away, which means we're really only left with 2x equals 20. Hey, that's just a one-step equation. Divide both sides by 2, leaving us with x equals 10. Therefore, we have the ordered pair 10, 0. Similarly, for the y-intercept, the 2 times 0 simply becomes 0, going away. Now we're left with not just 5y, but remember this minus we bring down, treat it as a negative. That's negative 5y equals 20. We have this one-step equation. We divide both sides by 5, leave it, or rather negative 5, don't forget the negative, leaving us with y is equal to negative 4, which we write as 0, negative 4. Let's plot both these points. 10, 0 is here on our x-axis, since it is an x-intercept. 0, negative 4 is here on our y-axis, since it is a y-intercept. Now go ahead and draw your line through your points. And that is the standard form.